Hello, everybody. My name is Warda Khader. I am assistant teacher at Ibn Khaldun University in Algeria. And today I will discuss with you my research titled Mapping Machine Learning Explanations with Designer Expertise for Input Variable Selection of Performance Metrics Estimation. So the outline of my presentation, first one, I start by context and motivation. Second, background, our proposal. Finally, we end by conclusion and some remarks. Let me start with architecture of a database management system. At the front end of DBMS, we have different users to interact with the DBMS by using its API. And at the back end, we have different components responsible to store and manage the data in efficient way. The main component responsible to optimize the query performance is Query Optimizer. This component is based on mathematical database cost model to compute the cost of each queries. The cost model can be defined as a function that has as an input a set of parameters to calculate matrix value for each operation by considering specific metrics. Operation in this case represent the SQL operation like join, scan, and sort, and each operation depend on the algorithm of implementation. For example, if you take join, we have three variants of implementation, depend on programming paradigms that can be sequential or MapReduce, and depending on emerging hardware of storage and processing. The parameters of cost model represent the variable that can be derived from the different phases of database lifecycle, conceptual, logical deployment, and physical design. And the metrics here represent the no-functional requirement related to the CPU cost, input-output cost, communication cost, energy consumption cost. Now, how to design a database cost model? The first scenario, the developer can try to develop a database cost model from scratch. In this case, the developer need to revisit all layers impacting the system to build accurate database cost model. In the second scenario, the users can try to search the cost model in the scientific papers. However, to reuse the parameters and the formulas of cost model, we need to extract manually the parameters and the formula from the scientific papers. In the third scenario, the developer can try to look existing database cost model in open source database management system, like for example, Postgres. The direct utilization of cost model from the open source DBMS, it's hard, require deep knowledge about database hardware, machine learning for calibrating its parameters, and statistic to estimate its parameters. Here we have an example of a database cost model to estimate the input-output from hash join operation. The different parameters of this formula can be derived from the architecture of database system. For example, we have some parameters related to relational operator layer. We have some parameters derived from the statistical data layer. The value of each parameters here can be estimated by using analytical model. For example, you can specify the number of page of each table in database by analytical model, or can be estimated by using machine learning techniques. For example, here, all parameters related to storage device can be estimated by using machine learning techniques. From this example, one can see, first one, designing cost model is based on the statistical or machine learning process. Second, the parameters to derive the derived parameters depend on designer's knowledge. So as a consequence, we need explainable AI as technique to bridge the user experience, developer's experience, and machine learning techniques. The research question here, how to map machine learning explanations with designer's expertise in cost model development. To resolve the problem, we have proposed a methodology based on three main steps. The first step, the domain analysis, in order to study the different dimensions related to database cost model. In the second one, domain modeling, we have linking the different components to represent cost model as a concept as in higher level of abstraction, and for the exploitation, the, the third step is a set of services to allows users to intercept, exploring, updating, and calibrating existing database cost model. This figure represents the global view of our proposal. So users here start by using our goal model. The goal model here specify, for example, the different component of database performance. And in the second one, based on the manipulation of goal model, we can provide a taxonomy of parameters related to many aspects, like for example, many aspects, like for example, query operation, the parameters related to metrics, the parameters related to database systems. And by using this taxonomy in interactive way, the next step is to use the machine learning techniques in order to compute the important and the importance of each input variable of the formulas. And in the next step, we try to map the machine learning explanation, that means the importance of the variable, and designer expertise. This representation present the different judgment of the entries of parameters from the cost function regarding machine learning explanation and designer expertise. In the third step, in the last step, we try to use existing data set in order to calibrate the parameters of the cost formula. The parameters in this case represent all parameters represented as calculated value. So for this step, we need first one, select the fitted model signature. Second, train the dataset generation, and finally calibrate cost model using machine learning techniques. To summarize, in this presentation, I have defined a methodology based on explainable artificial intelligence for feature selection with designer expertise. Our approach promoted flexibility of cost model definition by using our methodology in our system in interactive way, and improved the reuse of cost model design element. The element here represent the parameters, the fitted model, and the cost formula. And our approach suggests a template of cost model cost function signature. As future work, first one, we plan to design a visual language for cost model in order to provide rapid prototyping for design database cost model. Second one, exploring more the cost model element suggestion, adopting DevOps practice to automated the cost model deployment. Thank you for your attention.